Hello all.
Hi everyone. We'll wait for a few more minutes to let other people join. We'll wait for 2 more minutes for the people. Okay, we'll start now. So today we'll start with the very basics of machine learning, AI, what is AI, machine learning, and deep learning, how they are interrelated, different types of machine learning algorithms. So very basics we'll try to cover it today. So I would like to first introduce what is artificial intelligence. So artificial intelligence is like everyone knows feeding or making the system intelligent, behave like an human intelligence by introducing or inducing artificially uh, coded programs to it. Like I'll share my screen. So everyone knows that when we come across artificial intelligence, machine learning, and deep learning, so there is a very common Venn diagram you'll find on Google in which we have an artificial intelligence, then inside it will have machine learning as a subset of it, and then The subset of all two is deep learning. Okay. So artificial intelligence contains machine learning and deep learning. And deep learning is nothing but a special case of machine learning. Now we'll understand these things one by one. So now machine learning, as per Wikipedia definition, the machine learning is a field of computer science that uses statistical technique to give computer system the ability to learn with data. So in machine learning, what the system does, it learns from the data we feed them. Okay, it tries to recognize a pattern in the data, and based on those pattern, it tries to give a predicted output for a new input. Okay, like in traditional programming language or coding scenarios or computer system, what we have is our computer, and we give data to it, like input data, and a program, that is a code program. And based on this data, and after execution of this program may be in Java, Python, whatever, we get an output. Okay, output. But what happens in the machine learning is that we give a computer, we give the data, input data, and the output of it. Like there is a very common set of like, let's say there is a data, very common example of CGPA and CGPA and prediction, or the data set we have which a person or student is placed or not. Okay, so we'll feed these things, like one person is having a CGPA of 7.8, and we'll make it as like placed as 1 or yes, whatever. Then 6.2 placed as 1, 9.1 0 did not got placed, then 7.2 0 did not got placed. So this is a complete data set which we will feed to the computer. That is machine learning algorithm. Data is this input, what is the CGPA, and output whether that person is placed or not. So what the computer machine learning algorithm will do, it will try to find a relation between this input and the output, this input and the output. Okay, and then the computer or machine learning will try to generate a pattern between the input and the output. So whenever a new input comes in, like if I give a new CGPA to it, like 7.6, then based on the earlier pattern or the pattern between the input and output, like it has drawn some pattern, like this is the pattern. Okay, so based on this pattern, it will try to predict whether a person with the CGPA of 7.6 will be placed or not in the future. So this is what machine learning algorithm does. It tries to analyze the data, both the input and output data, and then predicts a pattern and give a output based on the new input data. But what happens in traditional programming is that we give the data and a program, a piece of code, like if else condition, some loop, whatever it is required for the execution of that program, we feed them, and we have a different code for each scenario, and we feed to that computer, and the computer does the execution based on the data and gives us the output. Okay, so this is what traditional programming is. Now, so there is a example, like I'll tell you about the history of machine learning. So machine learning is there in the IT history from last 40 to 50 years, but recently after 2015 or 16, I guess that it has gained its peak. And earlier, in what form it was there is that, like most of you have played a game called chess, online chess. Okay, so it was also a machine learning algorithm only. But in what we fed to this program is that, to the computer program or machine learning algorithm is that, we what the experts have done, they have taken the created a knowledge base. Knowledge base means they have maybe some expert, Vishwanathan Anand or Magnus Carlsen, whoever they have picked. They have tried to find out each and every scenario, like if the knight is going in this direction and other pieces in this direction, what would be the best possible way to counter that. So all these scenarios they have taken from an expert, and they have coded it. Okay, they have created a knowledge base out of it. Okay, and then this knowledge base is used when a new user comes in and plays the chess with the computer. Okay, so this is a traditional machine learning, you can say, in which we have like coded everything. Knowledge base has been coded with many if else conditions. Okay, so uh, what we can say for machine learning is that, from the recent discussion whatever we have done, machine learning uses statistical statistical technique to find pattern in the data. That's it. This is the core crux of machine learning. It takes the input and the output, both data, and it tries to get a relationship between the input and the output. And once it understands the relationship between the input and output, so whenever a new data comes into it, based on that relationship, it tries to predict the output. So this is what is machine learning right now. So any doubt with respect to this from anyone with respect to machine learning, whatever we have discussed so far right now? So this was machine learning. Now there is a special case of machine learning which is called deep learning. Okay. So machine learning has a subset called deep learning. Okay. So it is just we'll discuss deep learning a bit in the end. This topic I've kept at the very end. Uh, so it is just that the algorithm used here are a bit different from whatever has been used in machine learning, and it is this deep learning whole core concept has been derived from our biology, that is called neurons, and similar thing in deep learning is known as perceptrons. So perceptron is just a mimic of the neurons. Neuron is a biological part in our brain. So perceptron is just a mimic of the neurons, which is like a mathematical function only, which will understand step function and other functions, which is used as perceptron. And based on that, deep learning, complete deep learning algorithms has been developed. So we can say the basic unit of deep learning is perceptron. And in machine learning, what we do generally, when we feed the data like input and the output data, to a machine learning algorithm, okay, or a model, when training a model, machine learning algorithm. So we feed the features of the input. And what are these features? Like if we are going for a classification problem, like we are training machine learning algorithm to differentiate between different images like a cat and a dog. So we'll give different features to the machine learning algorithms, like a cat, uh, tail can be straight, dog, tail can't be straight, it will always be bend. Then cat has a big mustache, okay, and height weight ratio, something features will give to machine learning algorithms. So these are the features means the properties of that particular input, which we through that which machine learning can classify that particular input data, whether like we're taking cat and dog example, we have shown hundred of images to a machine learning algorithms, which are like a few of them are cat and dog, lion, horse, donkey. So based on this feature, whatever feature we have fed to machine learning algorithm, it will learn the pattern between those features and try to differentiate uh, cat and dog from other pictures. Okay, but what happens in deep learning is that we don't feed anything. We don't feed features. We don't feed them. We will just feed them the images, and it will learn on its own. Okay, using perceptrons. So this is a major difference between machine learning and deep learning. Okay, in machine learning we don't feed features, that is we don't sorry, in machine learning we feed features, that is we give the features of the input data. Be input data could be anything. If it is a image, we'll give different features of the image. If it is input data is maybe CGPA, IQ, then 10th percentage, and then placed or not. Okay, so this is for a student, BTech student. Okay, so in order to predict whether he is placed or not, these are called features. Okay, these are the feature of that student. We'll give the CGPA to it, IQ, then 10th percentage, and whether he is placed or not. Okay, these input data will feed to the machine learning algorithm. So based on this feature, it will try to draw a relationship between these features and the placement scenario. And whenever it gets a new input data, it will predict it, whether he will get placed or not in the future for the new student. Okay, so these are called feature. Okay, but in deep learning, we don't need to give this feature. Okay, just raw input data we can give, and it will learn on its own based on the experience. So this is the basic difference between machine learning and deep learning. And deep learning will understand very thoroughly when we'll start completely go into deep learning, because to understand deep learning you need to first understand machine learning first, because most of the concepts of machine learning and deep learning are interrelated. So any doubt, any confusion here with respect to deep learning and machine learning so far? Hello.
So, Venkat, for deep learning, so what is the input of information? It's a kind of images, or so machine
You can,
learning. It is
yes,
clear, but coming to deep learning, little bit of confusion on that.
yeah, yeah. In deep learning you can feed anything. Okay,
Anything. Okay.
we don't
Okay.
do much of pre-processing. When we'll go into deep learning, you'll understand. In machine
Okay.
learning, we do pre-processing of the data. And what is this pre-processing? Like, say, whenever you have done web scraping, you have taken lot of data from the Amazon website, e-commerce website. So many is on many unnecessary data will come. So we
Yeah.
pre-process those data, simplify it, remove unnecessary things from those data, grammatical, comma,
Yeah.
dot,
Yeah.
and all those things, and we feed to machine learning algorithm. But deep learning algorithm is like it will learn. Okay, it finds some error or loss in the learning trick. There is one called perceptron trick and different concepts there. It will keep on learning and improving itself. That is deep learning.
Okay. Based on the data, it is automatically process itself.
Yes, yes, yes. So that is
Okay.
the beauty of deep learning. Recently, like most of the model, if you go OpenAI, all are based on deep learning only. Okay. So machine learning and deep learning. So now the question would come, then why we are going for machine learning right now? Why we are learning machine learning? Okay.
Okay. Yeah.
Because that is the case, because you cannot apply deep learning concept or models in each and every scenario. Okay, if you want just a smaller project you are doing and deep learning models are very heavy, they require a lot of GPU and investment. Why will you go for deep learning? Okay,
Okay.
just a minute.
Mm.
And there are certain cases where ML machine learning performs better than deep learning, and deep learning performs better than machine learning. Okay,
Okay.
and what happens in the deep learning is that it generates the feature automatically.
Okay.
Feature automatically. In machine learning, we do it and feed it to the model. Okay, see, might be
Okay.
you would be finding it difficult to understand what are these features. I'm talking about features again and again. Maybe when you'll go into the future classes, you will have complete clarity what I'm talking right now. Maybe a bit confusion might be there. Okay.
Yeah, it is very early to ask the question. So maybe in the later stage we can understand. Okay. Yeah. Okay.
Yeah, see, I'll one just simple thing I'll give you. Feature is nothing but like if there is someone called Vijay. How do you differentiate Vijay from Ajay? Height.
Yeah, there are specific characters with
Yes,
respect to
so
each person.
these are known as feature. This
Yeah.
is
Okay.
how you differentiate and input data from other data. Like I
Okay.
have told CGPA, IQ, and these things of a student. So this will differentiate one student from the other.
Okay.
Okay.
Yeah, this
So
data feed to the machine, it is going to mimic the information, right? That is the machine learning. Machine learning part bit clear. Yeah,
okay.
this will
So
convince
you
that deep learning
in machine learning, you feed the input. Input
input. Yeah.
means features of the input and output. So what
Yeah.
machine learning will do, it will try to inference a relationship between these two.
Yeah.
Okay, see, I'll show you.
Yeah.
Just
Based on this,
see.
it is going to create one pattern.
Yeah, I'll show you one just simple example. Maybe just will this will help you get a more clarity.
Okay.
So this is CGPA and this is placed or not. Okay, so we'll take yellow as the people. Sorry, uh, maybe I'll take uh, these are the one who are not placed. Okay, somehow I am just giving an example, and these people are the one somewhere like this, some pattern it has drawn, who are placed. So how it will draw a relationship between placed and CGPA? It will simply check. It will try to draw a graph like this. Okay, so if a new CGPA comes in, what it will try to do, it will check if that CGPA, new CGPA, is following somewhat this pattern or not, following this graph, how far it is from this graph. If it is too far, that means that person will not get placed. It will give somewhat kind of probability kind of an output. Okay, A
Okay.
bit, got a bit clarity on this.
Yeah, yeah.
So it just try
ML
to,
part is clear, Venkat. ML part
yeah.
is clear.
So see, DL part you will get cleared when we'll do complete ML and go into deep learning. Just
Sure,
a
sure.
simple conclusion I'll give you that in deep learning we don't feed features. Deep learning generates its own feature.
Okay.
Okay. So now we'll start with types of machine learning. So we'll go not very deep, but yeah, bit deep into this. Not very brief also, not very deep also. Okay. So types of machine learning is basically categorized based on the amount of supervision is needed to get an ML algorithm trained. Okay. Now what is this supervision? I'll tell you. So there is one type called supervised. Okay. Then unsupervised, then semi supervised, and then reinforcement learning. Okay. Now we'll try to differentiate these machine learning types of machine learning. So for this, I'll try to open a PPT. So yeah, I'll take you through this PPT one by one, whatever I've explained. Machine learning enables system to learn pattern from data and improve automatically without explicitly programming. That without explicitly programming means we are not giving if else condition or different logic for different cases. Okay. So ML is the foundation of machine learning. This is just a basic theory. So yeah, this is what we have discussed. Machine learning is a subset of AI where algorithm learns from the data to make prediction or decision. Example, email spam detection learning from the past email. So this is one example of machine learning in real world is that you fed a lot of email to a machine learning algorithm. Okay, so that algorithm learned from that. So what we have done is that I'll give you in supervised machine learning example also. So what we have done is that we have given a lot of input data to the machine learning algorithm, and the data is like that. If it has the spam emails has a lot of discount word or grammatical incorrect word, then it is a spam. So we trained the models based on this input and the output data. Output data is whether it is spammed or not. Input data is what all the features we are feeding in. So based on that, the machine learning will predict if a new email comes in, whether it's a spam or not. So we'll take this example specifically in our classes.
So, but the thing is, I have a question here. So, as per like each and every day, data is getting vasted, and with that, we might have new things coming into picture. So, do we need
Yeah.
to feed the algorithms again and again just to keep it updated based upon data only? We have to do.
Yeah. See, this is one type of machine learning we'll learn right now, which is online based and then local based. So yeah, when you're working
Okay.
with an organization, okay, so that is what in deep learning it is hosted, so we don't have to feed the data every time. It takes the data and automatically learns. But when you are working in an organization and say you have securities related to data and you don't want to expose your data to the outside internet, and you have locally cached your machine learning algorithm, then you need to train your machine learning algorithm every now and then. Yeah.
Okay.
So see, different types of machine learning, it helps the tester design suitable validation strategy based on what machine learning algorithm is being used in the organization. So based on the machine learning algorithm, type of machine learning or algorithm, you have to design your validation strategy, which metrics you want to use, which metrics you want to discard, what all feature engineering you need to do. Okay. So we'll start with those one by one. So algorithm learn from data, neural network. So this I have already explained. Yeah, now we'll start. We'll supervise machine learning. So first is supervised machine learning. So in supervised machine learning, what we feed to the computer system or machine learning algorithm is the input data as well as the output of it. Whatever I have explained so far. Like same example I'll take IQ, CGPA and placed or not. Okay, we'll feed the data like some random numbers 87, 97, 8.2, 9.1, placed yes, not placed 0. So we'll feed them this input data also and this output data also. So when we feed this input and output data to the machine learning algorithm, it will simply, what I have explained till now, it will try to draw a relationship between these two, and it will that based on the relationship, whenever a new input comes in, it will try to predict a uh, output of it. Okay, so this is what is the machine learning, supervised machine learning. So supervised machine learning is very simple in explanation. We feed both input and the output data to the machine learning algorithm. Okay, now one more uh, one very important concept I'll explain you. In supervised machine learning also we have other types of machine learning. Now data, what data types in machine learning? And I'm not talking about integer string. So there are two types of data in machine learning. One is numerical data and other is categorical data. What is this numerical data in machine learning? Any data which can be numerically classified like age, weight, then CGPA and cost of a phone, cost of iPhone maybe. Okay. Now what is categorical data? Categorical data is which cannot be numerically classified. It can be categorized only, like name of a person, then state where he or she lives in, brand of the phone, then mm, color of his her eyes. Okay, so these two types of data we need to understand, numerical data and categorical data, and this is very important because we'll be very frequently using numerical data and categorical data in machine learning. Okay, now in supervised machine learning we have two types of machine learning. One is regression and just a minute. Yeah, so in regression machine learning what we do is that is a type of supervised machine learning in which the ML algorithm is trained on numerical data as output. Okay, so in supervised machine learning, regression is a type of machine learning in which we have trained the model, we have fed input and the output, but this output is numerical. We are not feeding categorical data. So this is uh, supervised machine learning regression type.
Yeah, that means is it operates only on the first data type, numerical data type.
Yes, yes, yes. In which we feed the only numerical data as the output data. Okay,
Oh,
like I'll give you an example. That same
yeah,
CGPA and IQ, this
yeah, yeah.
placed. Okay,
Placed,
like
yeah.
CGPA is there. CGPA is there. Okay,
The
now
output should be in
place.
the numerical format.
Yes, output is placed. Okay, so
Uh,
CGPA something we have. Output somewhere in the data we have like yes, no, yes, yes. So if we want to convert into a, regression form, what we will do, we'll replace yes by 1, no by 0.
mhm.
Okay. So this is one small feature
And what's
engineering.
the input? Okay.
Input
So
could
if
be
you're
your
expecting output,
only output should be numerical. Input could be anything.
okay,
Okay.
got you.
Input could be numerical or categorical, both. Now, there is one more type of supervised machine learning. This is regression, in which we have fed the output data on which the model is trained as a numerical data. Now in supervised machine learning, we have one more type of machine learning, which is categorical. And from the name itself, you can understand in this, we feed input and we feed output, but the output is a categorical data. Okay, name, state, etc. Okay. So two types of supervised machine learning. One is regression, another is categorical. In regression, the output data fed to the model for finding the pattern between the input and output is a numerical data. And in categorical data, you can simply see from the name itself, the output data which is fed to the model for learning or finding the pattern between the input and the output is a categorical data. So this is supervised machine learning. I hope um, clarity is there with respect to supervised machine learning. Now we'll go with unsupervised machine learning. So unsupervised machine learning, it is quite opposite of supervised machine learning. In supervised machine learning, we fed both input and the output data to the model to find a pattern between them. Okay. In unsupervised machine learning, we feed only input to the machine learning algorithm. We don't feed output. We feed only input to the machine learning algorithm, and we don't feed output. We are not feeding. Okay. So now we can say, like, if there is no output, then what this machine learning algorithm will do? If there is no output, with what relation it will try to find out? Because there is no other parameter to from with relation to it, it will try to find out any relation. So this unsupervised machine learning is used in different scenarios, like clustering, dimensionality reduction, anomaly detection, and association rule learning. Rule learning. So in these four cases, the unsupervised machine learning technique is used. Okay. Now we'll start with what is clustering. So we have fed input data, only input data to the machine learning algorithm. Now, what will it do with the input data if it is not trained on any output data? But it will try to find some pattern in the input data, and which will help us in future in different scenarios. Like if we say we have fed lot of input data like customers information to a machine learning algorithm, and those customer information we have taken from e-commerce website, maybe Flipkart, Amazon, whatever. So what it has done in the clustering, it will try to find similarities between the input data and try to group them into different cluster. This is one cluster of different customers, and maybe this is, sorry, and this is a different cluster. So based on the input data similarities between the input data, it what this algorithm try to do is that it try to find a cluster of different customers. Okay. So whenever a new customer comes in, say now a new customer input, it got a new new input data, that is a new customer. So it will try to find, based on this learning and clustering, it will try to find this new customer where it will fit in, either in this group or this group. Maybe this group could be like this customer is very uh, what we say, has the high tendency to buy a product from the online portal, and this group of customer has a very low tendency to buy from the portal, online portal. Okay, and this clustering it has done based on this input information of different customers and finding a relation like whether it has bought in the past or not, what is the average salary, which state and age group it is in. So whenever a new data comes in, it will try to put this new data into a different cluster, into either of the cluster. Okay, so it tries to, what the clustering does, it tries to cluster different input data into different group. So this is what is called clustering. So what clustering helps in is dimensionality reduction. Okay, now I'll tell you what is dimensionality. I'll not go that deep because this we will already cover in future. Okay, so like CGPA, IQ, and placed or not. Okay, so what machine learning algorithm tries to do, it tries to draw different input parameters and output parameters in different directions in a vector space. Okay, this could be CGPA, IQ, and placed. Okay, so in machine learning, right now we know there are only three dimensions as per our recent whatever scientific advancement we have done. We know there are three dimensions right now. So, but in machine learning algorithm, it hypothetically takes more than three dimensions. There could be 700 dimensions in machine learning. Okay, there could be other dimensions like this, like this, like this. So each dimension represents one feature of the input data. So what clustering actually helps? It helps in reducing this dimensionality. A bit confusing confusion would be there, what are dimensions and how it is reducing. So we can just analyze, say that unsupervised machine learning is basically help clustering the different data into different groups, and which helps in dimensionality reduction. And what is this dimensionality reduction? uh, for this, when I'll take statistics class, then you will understand maybe statistic and different machine learning algorithm. Right now you can simply understand uh, it plots the graph for the input data, different features in different dimension of the vector space. And when we cluster the input data into different clusters, this dimensionality got reduced. So if it is in 6 dimension, it will come down to 3 dimension. And this dimensionality reduction helps in increasing the efficiency of the model and speed up the execution time of this model. Now, one more example I'll give you of dimensionality reduction is that, say, uh, we have a data called for a real estate data, number of rooms and number of washroom. Okay. And we have cost of that particular house. Okay. I'm just giving an example of dimensionality reduction. So if you plot this now, the machine learning algorithm, what it will do, the ML model, it will try, just a minute. It will try to draw a pattern between input. What is the input? Number of rooms, number of washroom and cost. So what it will do, number of rooms, number of washrooms in two axis and the cost in the third axis. Okay, so it will try to draw a plot. A plot would be in 3D plot, maybe a plane. Okay, to find a relationship between washroom, rooms and cost. Now what dimensionality reduction we can do is, can we make this as a single feature as square feet area? So now if you want, earlier we had two features, number of rooms and washroom. Now we clubbed this into one feature called square feet area. Now the dimensionality would be square feet area versus cost of the house. Now if the ML algorithm tries to draw a pattern between these two, it would be a 2D pattern, maybe this a simple straight line, whatever. Okay, so this is the glimpse of what is dimensionality reduction. So this clustering helps in dimensionality reduction as well, and it helps in unsupervised machine learning through clustering. It also helps in anomaly detection. Anomaly detection means finding unexpected behavior, unexpected cases. Like this is a case. It has tried to draw a pattern. It has clustered different customers into one group, different customers into one group. Okay. Now it got a new customer and that lies somewhere here. So this is an anomaly, very unexpected case. Okay. So see, the main crux of it is we have not fed any output of it to this model. So based on the input only, it is trying to do so much playing with the input and trying to infer. We can infer so much knowledge from this input itself, which will help in simplifying the prediction and making the prediction very efficient. Okay, so this is the case when you don't have the output. When you are working in an organization or on a project and you want to do something with AI ML, but you don't have any output data, you just have an input data. So in this case, in unsupervised machine learning, you can, with these clustering, reinforcement, anomaly detection, dimensionality reduction, you can play a lot with this input data, and you can prove that with this limited data also we can leverage the models and give a lot of input to the project. Okay, so this was unsupervised machine learning. Now we'll go with, so one more example I'll give you on unsupervised machine learning is maybe uh, anomaly detection is that somewhat like, see, we have input data of an engine, aircraft engine, like heat and vibration. We have a lot of input data. Okay, these are the existing data. So model is trained only on this input data. But suddenly in the aircraft engine, we got one data something like here. This is an anomaly. It will simply trigger an email. We have a model like that. We can create a project like that. If there is any anomaly in the input data, which is not at all close to this data, which is the expected data, it will simply trigger an email to the team like stop the production or go for the maintenance of this particular aircraft engine. So here also in anomaly detection can be used. Anomaly detection can also be used in share market analysis, where when there is sudden jump or dip in the share market. Spam detection, very unexpected spam scenario came into the market. So in this case also anomaly can be detected. Okay, then we'll go with semi supervised machine learning. Semi supervised machine learning. So it is partially supervised and partially unsupervised. This is semi supervised. So it requires a lot of human effort. Why? A lot of human effort. Because in semi supervised machine learning, we label the input data ourselves. So we label the data ourselves. One example is that Google photo, Google pictures or Google photo. In this, what we do when we click a picture, there are many person in that. You just label a person as your brother or sister. So based on this labeling, whenever a new picture you'll upload, then it will automatically detect that person as your brother and it will label it. Hello, Sai, can you mute yourself? Hello, Sai, please mute. So in semi supervised machine learning, what we do is in the input data we label the data ourselves. Like in Google picture we have seen that if you label someone as your brother or sister, in the further pictures when you upload, the Google models will automatically detect that person and it will label it as your brother or sister. So this is an example of semi supervised machine learning. So in semi-supervised machine learning, what is there? Partially supervised and partially unsupervised. So in partially supervised, when we take the data from anywhere, it is already labeled. And in partially unsupervised, there are few data points which we have to label it. Now we'll go for the last one, which is reinforcement learning. In reinforcement learning, we don't provide any data to the machine learning model. The model, no data is provided to the model. The algorithm starts learning from scratch and then improves slowly like human. Like example of it is self-driving car. No data is provided to the model. Model itself learns on its experience and improve itself. Like, I'll tell you how it does this. So there is an agent, it performs an action, then it gets a feedback in the form of reward or penalty, and then updates its learning path. Updates its learning path. And this loop goes on again and again. So this is where reinforcement learning comes in. Like we train a dog, similar kind of it. How dog training is done, we train it and we give reward for the correct action and penalty for the wrong action. So that is how reinforcement learning is. So any doubt till now? Any confusion, doubt?
Sir, only thing is, by looking at the techniques, how to find out that what to use when, which technique to use when.
Which technique to use when? Okay, see, these techniques are used basically when the model training is being done, and model training is done by the AI engineers. Okay, so you need to know this basic theory part, and when you will do the model validation part, okay, when you will try to build your model, so in different scenarios you can take like it also depends on the type of data you have. If you have the input and the output data, you can go for supervised machine learning. Okay, when you have the input, only input data, then what else you can do with the input data, how you can play around with it. If you don't have an output data, then you will go with unsupervised machine learning. It depends on the project you are working on the AI team you are working with. If the AI team is not at all dependent on machine learning, they are using deep learning, then you don't have to do all these things. Sometimes these parts are taken care by the AI engineer. Okay, and when you don't have any data, then you go for reinforcement learning. Okay, so what I have explained till now, this is a bit of theory of it. So this will help you in your interviews. Okay, and when you will go to the practical, uh, most things are done by the AI engineers. Okay, in practical, we'll just validate the models. We'll understand in graphs, in different dimensions. Will plots, how it is plotting a graph, how it is finding a relation between the input and output. We'll validate those graph models with those graph, and we'll tell different scores and metrics how the model is performing. This is our core area. Okay, but when you are doing an using an AI agent, okay, so most of the AI agent right now is deep learning, based on deep learning also. So there is one more thing is that deep learning versus machine learning. Okay, so when the data, sorry, not this one, there is one more thing is that, so deep learning is definitely have an edge over machine learning, but when the data increases to such a limit, there is a limit in deep learning after which the performance of the deep learning is almost stagnant or it decreases. Okay. So in this case, if you have this threshold known, then why you will go with the deep learning model? Why won't you go with machine learning model? Okay. Because deep learning model will require a lot of hardware and cost involved, time involved. Take lot of time on training, giving output. GPUs are involved. Okay. When we'll go deep into machine learning, you will understand the core difference between deep and machine learning, when to use machine learning, when to use deep learning. Okay. When you have very limited data, very small data, very small project, very small data set. Okay. And very small project you are doing. In that case, you'll go for machine learning. not deep learning. Correct. So this is the overall today's session on types of machine learning models, supervised, unsupervised, semi-supervised, and reinforcement learning. And then there are few more types of machine learning which are like batch and online learning. Okay, so these I'll take care maybe next session.
Yeah,
Thank you all.
Venkat,
Yeah, yeah,
Venkat, one question. Like once you mentioned we are going to identify which kind of testing we are going to do, like
yeah.
supervised and unsupervised.
Hmm.
So at the time of once it is identified, so are we going to apply any kind of algorithms or how do we evaluate? So
Yes, 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 yes. See,
okay, that
so these types of machine learning is mostly a theory for us right now. Okay.
okay, yeah, yeah,
Now,
okay,
now we'll go with say we'll test different models like
mm,
gradient descent or decision tree. There are different machine learning algorithms. Okay.
okay, okay,
So
yeah,
we'll use those algorithm. Okay. We'll test them. We'll play with, we'll train them on some data. Okay.
okay,
Then we'll test them, find the output of the metrics. Okay. And
mm,
then we'll kind of for each models will do a prediction also, like whether this metrics or is correct or not. Then what is the difference between two algorithm, like there is one decision tree is there, then gradient descent is there. Okay, then logistic regression is there. Okay, what are the difference between them? We'll apply them on different test data, then find the metrics output, and I will show you these things. We'll
okay,
do
yeah,
hands on, no, then in the code will show this different models are performing differently, giving different metrics, different output. And then we'll validate, yeah, great, decision tree is doing good on this particular data set, and gradient descent is not doing good, logistic regression is doing best, then we'll go with this particular data training model. These things will do hands on,
okay,
theory
okay,
plus hands on.
yeah, 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 okay.
So is this will be done with group of people or this one person is doing? Um,
Sorry, I didn't get your question.
no, no, in the team, like, is it done by as a team or just one person will be doing, like, it'll be assigned, the task will be assigned to one
Training.
individual.
No, we'll do as a class, like everyone would be doing same thing.
Okay, no, no, in the industry,
Maybe
there
maybe
is a
she's
real
asking about
case,
the information, Venkat, like
real.
decision tree, all the algorithms.
Ah,
So so I think it
no,
is depends upon the
no,
data.
no, no. See, when we'll learn scikit-learn or different classes, no, there is
Mm.
just one or two lines of change in the code, and you will get different output. So we'll do everything parallelly in this. Like in the same code, we'll write the code for decision tree, then gradient descent, then logistic regression. Then we'll try get the output of this, and we'll test it. We'll do simultaneously. I hope this is clear.
Okay,
Any?
yeah, got it, got it. I was actually talking. I spoke about a real case scenario in the industry that
Okay.
the task. Yeah, yeah, yeah.
Yeah. No, in real case, it depends how big is your training data. Okay. If someone
Okay,
is testing on decision tree, or if one, how big is your project? Okay. It requires how many
okay,
resources. If one resource is enough to do this, that's fine. Okay. If two, three resources are required, that's a different scenario.
okay, got
Okay.
it.
Okay.
Yeah. Yeah, how about the notes, Venkat? Like you told
Yeah.
so
See,
many things today.
see,
So you are going to provide any notes for this class, or how is there any
uh,
document related to this?
see this basic notes for first one or two session, like
Okay.
today's session, supervised, semi-supervised. If you want, I'll provide the notes for you, but from the next class I'll be providing notes in Jupyter format. We'll install Jupyter. We'll ask everyone, guide everyone to install Jupyter on their local, and we'll do everything hands-on, and like Python for AI and statistic. In those cases I have the notes, so I'll be providing notes like this, somewhat like this.
Okay,
So
okay.
nodes would be something like this. What is precision recall? Then in
Oh,
the Jupyter, we can execute everything. Like this is the thing. Like we can execute this particular piece of code. We'll get the output of it. Then training. So this I'll provide a code in nodes in somewhat like having the code plus the information or understanding of that code itself in the nodes itself. Okay.
okay, sure.
So today was just the basic session, so that's why I thought this is just the basic, not much note is required for this, because this is a completely logical part. Not we cannot explain features and through much detail in notes format, right?
No, I'm just expecting like, so you mentioned supervised, unsupervised, some
Ah,
kind of theoretical information is there, right?
ah,
So
ah.
this is the first time where we are hearing all these words. So if you provide, so we are going to repeat what kind of definition in that, so that what kind of examples. So
Okay,
we are going to revise those information, right? That would be help
okay.
us.
See, I'll one thing is that you will get this recorded session, and
Yeah,
this
yeah, yeah.
whichever class you don't get any notes, I'll provide you notes in the very next class. Is that fine?
Okay. Yeah, yeah, yeah. Okay. Thank you.
Okay, like today's class
Also,
notes, maybe I'll provide next class.
sorry, today is my first day in the class. I just want to know, like, once I finish this course, what
Mm.
certifications can I pursue?
Certifications you want means what career you want to pursue, or you will you be able to pursue?
I
Is
mean,
that the question?
I just want to know, like, you mentioned in the before that, this part will be taken care by AI engineers. So I'm
Hmm.
assuming there will be a certification for AI engineers. So similarly, after finishing this course, what certification would I be able to take?
Okay, I got your question. So I'll this I want to explain everyone right away. So in the data science or AI field, there are two kind of person. Person one, this guy is an AI engineer or data science, whatever we say. He has complete knowledge of model building. He builds the model and trains the model. Then there is one person which are tester and developer. They use the machine learning models to build their project. Okay, like they're using chat gpt or copilot or cloud. Now what through this course we'll be doing is we will be somewhere in between. When this is the real scenario what the market is looking for, someone who knows how to use the model and also knows what goes behind the model. So after this course you can I'm not sure if you give a bit more effort, you can go into the AI field.
Okay.
Okay, and if you don't want to give much effort, you just want to use the model, you can go into this field. But definitely when you are here, you have an edge of clearing most of the interviews of the product based companies. This is one thing I can guarantee with you.
Okay.
Okay, because
Thank you.
you know how to use a model plus what goes behind the model. We are somewhere here. We are learning the models, whatever theories and practicals, to such a level that we are not going very deep and not very shallow. Is that fine?
Okay. Yeah. Thank you.
Yeah,
So
thank you.
This
I
is
have
a little
one question.
further, yeah. After, sorry, it just,
Yeah.
yeah, it's quick question. So this is just further question of this. After the certification, what is the title of the jobs or anything we can just look for? um, Any job
Mm,
portals?
see, you just what you do, one task I'll tell you, maybe you can do it, everyone can do today. Yesterday also I told, you can write anything, search any job with automation or testing slash AIML. Just give this in the job search. Okay, you will get lot of job with this, in which they are looking with the person with automation knowledge plus they have given like something preferred if they have ML knowledge. Okay, because now these days only automation knowledge will not help you out. Okay, they want automation with AIML. Okay,
Basically,
this is
what
what.
is the
This is
outside.
one
Or
kind of
what?
job. And other thing is, in many places you will find AI validation. Okay, AI validator or validation. This is one job scenario is there. Then AI testing. This is one case. And other case, whichever in domain you are in, you can add AI ML to your resume.
Okay, so there won't be any particular tool associated or connected with this AIML. Like you have to be like Python, PyTest, or anything like that. Any automation tool would be fine.
See, we will be learning Python, pandas, whatever the Python basic Python required for AI ML will do that. Tools will generate our own AI agents. Okay, N8N will prefer. LangChain will do. LangChain is a framework that will do. Okay, N8N will do. Then these two things I'm majorly focusing on, and LandGraph, if time permits, will go with that. Okay, this automation of complete framework for AI using AI ML. Okay.
Okay, okay, got it.
Here will not be going to use the tools like Selenium, APM, because those tools are already with integrated with this AIML and different kind of frameworks. Okay.
Okay,
Sir,
that also we'll know in this course, how they are integrated or
That then we'll have to go into Selenium and other classes.
okay, okay, okay.
Okay.
Got it, got it.
Because see, using a tool is not a big case right now. You can, uh, but understanding the tool is the big thing. What I feel. What goes behind, because
Okay,
this is majorly, you can say, your hands on plus focus on interview clearing. Okay.
okay, got you, got you. Thank you. Someone else is waiting
Yeah,
for the
I have a
question. Sorry.
question.
Hello?
Yeah.
Yeah.
Yeah, yes. So,
Yeah,
so
actually, you
actually,
have told here about AIML, right?
Hmm.
Oh, but like we should learn machine learning also because I'm from testing background. I was just interested on only AI testing. Okay.
Okay.
So how it will be helpful because this is AI or ML you have given, right? So
Hmm.
what is that like AI or ML difference? I mean, the main we need to learn machine language also, like AI, ML, and what we need to require for AI testing. Because I see it's very more than data analytics and data engineering. This AI looks complex, right? So can you give
See,
me difference of all this data analytics and AI and what are we looking out here strongly?
see, data analytics and data science, that is a completely different field. Okay, though they are related to what we are learning right now. So data science and data analytics is what they play on the data, they train the data, the model building things, that is related to that. But here we, what we are doing is we are trying to use the models.
So who will
And
build the model and how do we build the model?
no, we cannot build the model, because to build a deep seek, to build a chat GPT or OpenAI models, they have taken billions of dollars to build one model.
Who is building that? Like data engineers or
They, a team is there, data engineer team is there, data science team is there, then people from statistic background is there. People they play a major role. People who have done PhD in mathematics, like linear algebra and all those things, they will be there. They will sit, they will take billions of data, and there is a complete different team for it. Okay,
no,
we cannot.
because you
Hmm.
you are telling AI tool is built by them. So
Ah,
so for that, like, is it require a prompt engineering to build or like what are the skills requires for that to build a AI tools?
see, to build a AI tool, we just need to know different components of an AI tool. Okay, just we will learn different components of the AI tool. Maybe when we'll start with the LangChain, you will understand data pre-processing will go through. Okay, how we do pre-processing of the data. how we use a model, how we give a prompt to a model, how we analyze the log from a model. These things will do. We'll understand different components of the complete AI chain. We'll integrate them and build our own solution.
No, you said no data engineers or some statistics people will build the AI tool, correct?
They will build AI models. Tools are already built. Okay, will the major part of it is testing and how to use a tool. Means how to use it from the backend code point of view.
No, I didn't know the difference between models and tools. Can you please tell that?
See, ChatGPT is a tool, but behind ChatGPT, there is a model working on. Okay,
Correct. So that is the
uh,
data engineers will do. You are saying correct?
that is already done by them. Now they are training it again and again and upgrading the models. Yeah,
Huh. So the prompt engineers will work on AI tools, correct?
prompt engineers they just draft the prompt because a minor difference in your prompt can give you an absurd output from a model. Okay, they draft the prompt. Okay, so now you go to chat gpt, ask some question related to anything with respect to your uh, manual testing or automation testing. You just modify the prompt every time with the same question, just minor modification. You'll see a different result. So there
Hmm.
the prompt engineer comes in.
Okay, to become a prompt engineer, I should know AI. I mean, I mean, AI fully how it developed. We should know is uh, uh,
See, prompt engineer, I'm not much aware. There are different kinds of prompt, dynamic, few short, and other prompts. So they will simply draft a prompt like that. It will ask the model, like you are an automation engineer, you are doing validation for this document. Now you are an expert automation engineer, you are doing validation for this test cases, or you are automating these test cases. So this kind of prompt it will create and feed to the model. Okay, so they know
so
how to play with the language.
okay, see, as you said, to build AI tool, models are required. So,
Yeah.
if a model is built and we are doing through prompt engineering,
Mm,
the process from the AI tool to model, we are
mm.
connecting through machine learning Python, is it? That's a
Ye-
architecture I'm asking, like, or the concept of I'm asking AI, ML, and all this kind of chat, how it is interrelated.
See this chat. Uh, I'm a bit confused with your question right now because
See,
you
you
want what
said
us.
AI tool is
Mm,
built by models, okay, machine
uh,
learning models. And
im-
when you write a prompt in any AI tool, that's a
uh,
prompt that will understand by models. Okay, so what is the
yes, yes,
communication means? Definitely, machine will not understand our English, so there will be some
yes.
Python. That is what I am trying to ask you, rather than.
Okay, okay. I got it. I got it. Say,
So you tell me
so
the
the
interface components. How do we build models? Means how they built models and what techniques they're using to build models from first step. And second is how the when we write a prompt in AI tool, how it will understand the model. That is my main question.
See, if you go through the table of content of this course, you will find one place feature engineering. Okay. In that feature engineering table of content, in that case, I'll make you understand like how the model understands when we are talking, giving some prompt to it, how it is understanding the context of it. So in that table of content, you will understand that. Okay. And other things like how the model is performing, how it is giving an output. These things we'll understand when we'll start the ML algorithm classes. These are there in these classes. If you go to the table of content one by one, and if you are unable to figure out like what is that, I would suggest you please Google it out, and then you will understand what is exactly covered. Because this is a very lengthy table of content, and going through each part won't be very easy for me as of today.
No, on a very high level, my question was like, so you told algorithm is different and Python is different. So to understand our communication on the AI tool, we are
Mm,
writing in English language and the models which they have trained
uh,
uh, algorithm, which
mhm,
algorithm we don't know. Okay.
mhm.
So in this course, I will learning which algorithms they are using and means algorithms, how to write algorithm. And also Python also is the media of communication between AI tool and model, I'm asking you, machine learning means what?
Yes, 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 yes,
So
yes.
machine learning itself is a model, sorry, it's a Python language. That's what you're telling?
No, machine learning is different. It's a domain in which there are different models which are built on using Python. Okay, model is nothing, but it is simply using mathematics in Python language.
Okay, okay. So that algorithms also we need to learn mandatorily, sir, or
No, no,
like
no, no. We'll just overview of the algorithm will do.
okay, so
Over.
we are not supposed to do in office how to write algorithm, right? I mean,
No, no, that we can't do right now. That's beyond our scope right now.
so if you tell like we are learning AI ML means in a very high summarized, so what like our roles and this one will be there in the real time. What we are supposed to do in the corporate role? Can you tell us?
What you are supposed to do in real time.
Yeah, what is our roles when it comes when you finish this course? So in
Hmm.
like what we are expected to our getting role in organize like what we are supposed to work on that.
See, if you're already working in an organization, if
Mhm.
you're an automation engineer, you can contribute using these AI models, how to use them, how to create a chain of them, how to create a pipeline with them, and in your projects. That is one thing. Okay, if you want to switch into AI testing, then there
Mhm.
are a lot of job cases in which you can use apply for AI validator or AI testing or automation engineer with AI ML knowledge. Okay, I can say simply it is kind of upskilling class. Is
So
that fine?
there is no separately as a AML role or engineer. It has to be integrated with AI testing or with automation, you're telling. So what I
Yes.
was thinking is generally like how we have a developer, tester, business analyst, like AML engineer, separately, not like that.
No, no, AI ML engineer is different. That is a different domain. In that, they build the model and the data science is involved. That is a different case. Okay, in this, we will be learning how to use these models, how to create a pipeline. If you're using some tool to automate, testing some IFUs or some documents, if you're using the automation tool, then how you can bring in AI ML in that and reduce that effort from one month to 8 to 10 minutes. How you can do that?
Oh, so I was assuming that from the beginning that we are in separate, like what you said, that data science, AML, separate engineer, that we are going to learn. I was assuming that.
No, no, that data science class is different. I think that is a different class hosted by Isha Foundation.
No, normally AML means I thought we are that engineers and we are doing that full role in that.
No, that would take more than 6 months. That class is
So if
different.
you're a manual testing background,
Mm.
AI testing, you said, what is the test tool we can integrate with that? Any AI separate tool is there for manual testing to like
See, AI test in this. Uh, I'm not sure about what manual testing tool you are using. Okay,
there is no
because in
tool, sir, but we use Jira tool or a, Visual Studio just for a
mm,
test management. Even if you're doing automation, so
mm.
there will be. I have just read somewhere test rigor tool will do automate all this kind of with integrated AI. If I don't, I'm just read somewhere test rigor. You might have heard it, right?
There are a lot of tool in the market right now. Okay, so that tool learning process, I think that is not that hard. You can a lot of courses are there, so you can learn how to use that tool. But what goes behind that tool, that is what we'll be covering here. So that maybe you can use your own tool, you can use your own models in your project.
Okay, can I know what tools are we learning here?
Here we'll go with LangChain, then model validation will use different metrics and we'll use Na10 and if time permits, we'll learn Olama also.
Okay, because normally we know Jira tool and all that management tools like Jira, this one, right?
See,
Microsoft
whatever
Visual
tool,
Studio.
most of the tools now have their own built-in AI features. Okay, correct. Now in future also most of the tool have their own built-in AI feature. Whatever work which we are doing with the tool in maybe 1 or 2 days with this AI built-in AI features, it won't take more than 1 hour in future. Okay. Like Selenium has already come up with its own AI features. APM has come. Okay. So those companies are doing their job. They are getting us the tool.
So then, whatever you mentioned, all these things, how to integrate when you're doing with Selenium, as you said, to our existing tools. So how do we integrate with this?
Maybe I'll give you, I'll take 2 minutes.
Uh, Sir, in the
Yeah.
meantime, I had one question, quick
Yeah.
question. Sorry to interrupt.
Mm,
We spoke about a lot of couple of models,
mm,
different type of ML models,
mm,
right? Supervised, unsupervised, and the sub
mm,
categories of it.
mm,
So our testing approach, whatever we are following in this course
mm,
curriculum, right?
mm.
So that is irrespective of whatever the model is being developed, whatever the means like supervised or unsupervised or hybrid, whatever. Let the model be developed by any tech, by using any type of method. Our
Okay.
testing approach, what we learn, is valid for every model, or is it specific?
See, that is not specific. Those are the concepts you can use for any model. We'll be
Okay.
applying those concepts. Okay. There is no particular testing because when you ask something to a model, every time it might give a different result. These are the probability. Okay.
Uh, I got it, sir. Like what I wanted to ask is, sorry, it's getting right, but just let me be very quick. Uh, what I mean to say is, like there is already a model developed, for example, ChatGPT.
Hmm.
So we are using our strategies to test its accuracy, right?
Yes. Yes.
So these strategies which we are implementing, right?
Uh,
So that is irrespective of how that ChatGPT is developed, whatever may be the method they
yes.
have
Yes.
followed to develop
Irrespective.
that model.
Yes.
Yeah, got it. Yeah, that's what I wanted to check.
Yes.
Thank you. Thanks.
Yes. Because see, I'll give you simple example. When you are calculating an average of few data, so that is irrespective of the data, right? It will give you average every time with the same formula, right?
Yes, yes, sir.
So
Got it.
in
Yeah.
model also we are just applying mathematical formulas in coding format to get an output, to get a score threshold score, and we'll check the model working based on those score. Okay.
Sure, sir. Got it. Yeah.
Okay.
Thank you.
Applying mathematical formula to a model to get to judge a model. That's it.
Hello?
Yeah. Please.
Yeah, like as we are discussing that, see now we are using one tool like Jira tool, okay, for all
Uh,
creating case test design
hmm,
and execution or anyway that is happening manual. Now I
hmm,
need whatever you said that Lancet framework, whatever like
hmm,
or is
hmm,
Java Selenium means it's only we are writing Eclipse in Java tool and Selenium framework. So
hmm.
how do we what and all you told that kind of things which I have not heard. Like how do we integrate with this our existing manual and automation? Can you please tell me?
See, this though completely depends on your project, what you are working on. See, recently I'll tell you what I have done. I was a manual engineer way back a few years back. Okay, then I moved to automation, DevOps, and then now into AI with automation and DevOps. This is my role right now. Okay, so what I did simply, we used to I'll give you example. In my firm, people used to validate, there are like 16,000 page PDFs, and in different language they used to do the validation using the test cases. Okay, they will check particular text whether that is present in the that PDF or not. So this is one scenario which I picked up in my firm, and I told this manual validation, because we don't have a tool right now in which you can put a test case and you will get a validation result from those PDF. So in this test case, what I did is I took a model, I used the Langchain framework, and I put this PDF as the input and our test case as the input, and with the work which used to take 3 months was done in less than 2 hours. So these scenarios you have to identify. Maybe you can create your own mini projects and put it in your CV resume.
No, that only I'm asking. I'm not getting answer. Like, see, now you told Lancet framework, so many other tools, something, right?
Uh, hmm.
So how do if you're doing automation, Java Selenium, or if it's a manual, like in whatever we are learning this one, how do you integrating with that? Like any tool is there between, like how do we, that is what I'm like.
See, there is no UI for this tool. We will doing completely backend. Okay, backend testing, and there is one tool which has these UI thing which you are talking about. Like you are thinking it of like using some tool like Jira or Selenium. That is one tool we learn. That is N8N.
10
N8N.
N8 okay, because in
Okay.
test rigor tool I saw using AI to chat GPT, Gemini, Copilot, whatever. It
Uh,
was automating that tool. They maybe it's the plugin or whatever. So
uh,
that is what I was thinking by this.
no, that we are not doing, because using this course is not about using a tool. Except N8N, no other tool. I'll not be teaching you how to use Selenium, how to use Jira, or any other AI tools, because the lot of videos and content are there in the market. To using a tool is not that much easy, that much tough right now. Okay,
No,
because
because
those.
you
Hmm,
said we are learning this and we incorporating in our projects, right? So that is what
hmm.
I'm asking the process. N8 N8 only how do we integrate with our project what we are working?
Ma'am, how can you see now without understanding what N8N is, how we use N8N? How can I explain you? If I start explaining you N8N, how can you integrate in your project? Will you able be to understand it right now?
No, I'm not
No.
asking now today, but is it a process? That is what I'm
Yes,
asking.
yes, yes,
Yeah.
yes.
And the last question is, sir, featured engineering. You mentioned one word, no? So that
Yeah.
what can you please tell what it?
See, feature engineering, when the classes will start, maybe today I gave an example of feature engineering in the class today itself, where CGPA and IQ and placed those things I have put, and those CGPA and IQ was one of the feature of the student. So maybe if you go through the today's recorded session, you will get a glimpse of it. What are these features? And feature engineering, when we will start, then you will completely understand it end to end, because that is a different module itself. Is that fine?
Just I thought one summary high level. If you want to tell like future engineering.
See, another it would already we are going beyond time, so maybe I would request you to go through the demo session today, okay? And when the feature engineering class will start, see through these courses also in mid, I'll in different modules I'll talk about different features, okay? In that case itself, I can explain you like what
Oh,
are these features I'm talking about. Feature means simply to identify one person from the other. What are the feature properties that person has? Like he's tall, he's dark, he's fair, he's short, he has a curly hair, he has a brown eyes. So these are feature of a person. So similarly in data also, different data has different features. So feature engineering is nothing but a domain in which we process this, create these features or deal with them. Okay,
oh,
this is just a high level of it. Okay.
okay.
I understand the difficulties right now because this is a completely new topic, but when everything starts, when you will be in mid of this course, you will understand what I was telling, what different things are working. Okay, is that fine?
Yeah.
Yeah, thank you all for joining.
Thank
Thank
you.
you, sir. Yeah, thanks.
Thank you. Thanks.